Match the following. Column 1, we have at equilibrium NH4I solid gives ammonia gas, HI gas if pressure is increased. So this is the system where ammonium iodide is a solid giving ammonia gas and HI gas. So delta N is positive. Therefore, when pressure is increased, equilibrium shifts onto the left hand side. Therefore, reverse reaction is favored. So forward direction reaction favored is wrong. No effect on the system at equilibrium. There is an effect. Backward direction reaction is favored. So R is right. Final pressure is more than initial pressure. Initially only ammonium iodide solid is taken. Later as it decomposes to give ammonia and HI, the pressure increases. So S is also right. Equilibrium constant remains constant. Equilibrium constant will always remain constant for a given system at constant temperature. So as temperature is not mentioned, let us take it as constant and T will go with R. So therefore the answer for A is RST. So for A, we have the answer as R, S and T. Because delta N is positive, so increase in pressure favors backward direction reaction. Let's go for B. 2SO2 gas plus O2 gas giving 2SO3 gas. Here the number of moles of products are less than number of moles of reactants. So delta N is negative. So if the volume of the vessel is doubled, and we know keeping the temperature constant, when the volume of the vessel is doubled, pressure will be decreased. The decrease in pressure favors the reverse reaction. Therefore, once again, we have the backward direction reaction is favored. And here 3 moles are giving 2 moles. Final pressure cannot be more than the initial pressure. S is wrong. Equilibrium constant remains constant at a given temperature for that system. So T, R and T are correct. So for B, since the system is 2SO2 gas plus O2 gas giving 2SO3 gas, we have delta N is negative. And here volume of the vessel is increased, doubled. So at the given temperature, pressure will be reduced to half. When the pressure decreases, the reverse reaction is favored. C. H2O gas plus CO gas giving H2 gas plus CO2 gas. Delta N is 0. When delta N is 0, inert gas is added at constant pressure at equilibrium. Whenever inert gas is added for a system such as delta N is equal to 0, whether it is added at constant pressure or at constant volume, it will not have any effect. So no effect on the system at equilibrium will become right. And here delta N being 0, final pressure cannot be more than initial pressure. So equilibrium constant remains constant is also right. So therefore QT. So for C option we have QT. Since the system is in such a way that delta N is equal to 0, inert gas addition will have no effect on the system at equilibrium. Then what about D? In D we have SO2 Cl2 giving SO2 plus Cl2. 1 mole is giving 2 moles. So delta N is positive once again. Here Cl2 is removed. When Cl2 is removed from the system at an equilibrium, forward direction reaction is favored according to Le-Chatelier's principle. So thereby forward direction reaction favored is right. And here since delta N is positive, final pressure is more, and this is always right. So we have the answers as P, S, T. So for D, we have P, S and T as the options. Here from SO2 Cl2 gas giving SO2 gas plus Cl2 gas. What is that? We have delta N is positive 1, and here chlorine is removed from the system at equilibrium. So when one of the substances from the system at equilibrium is removed, the equilibrium will move into that direction so as to compensate the loss. So the forward direction reaction is favored.